and welcome to Cubit Education. In this lesson, we're going to learn how to solve simultaneous equations using the elimination method. Our objectives for today's lesson are to know what a simultaneous equation is and to use the elimination method to solve simultaneous equations. So first of all, what are simultaneous equations? Simultaneous equations are equations involving two or more unknowns that are to have the same values in each equation. So for example, you could be given something a bit like this: 4x plus 2y equals 8 and 6x plus 3y equals 15. Okay, you'll be given two equations like that. These are called simultaneous equations. You probably can't solve that one, I just made it up. But basically the x values will be the same, so we will have a value for x, and the y values will be the same, so we will have a value for y. And our goal is to find out what those two values are. And we are going to do that using the elimination method today. So let's have a look at this first example. We have, this is a nice example. X plus y equals 6 and x minus y equals 2. So what we have to do is we either have to add or subtract these equations from each other in order to eliminate one. What's nice about this equation is our x values and y values are currently just 1. So we only have one x and one y, whether that's positive or negative, in each equation. So we've only got one x there and there, and we've only got one y. Obviously this is a minus y, but there's still only one of them. So this is going to prove to be a nice question for us to tackle. You also need to be able to add or subtract negative numbers. Okay, so I really urge you to revise that if you're not sure about how to do that. Okay, add and subtract negative numbers. Okay, and sometimes times and divide as well. Now, because this equation only has one value for x, so one coefficient of x, I should say, not one value, but one coefficient of x, meaning there's only one x there, okay, and one x there, and it only has one coefficient for y, which is usually the number in front of those letters. Okay, because of that, we don't really have to do much to this equation. However, in other examples, we might have to change those equations to give us a coefficient for x or y that is the same. Okay, and we'll come to those examples later on in the video. Right now, we just need to look at these equations and we need to try and eliminate an equation either by adding or subtracting. Okay, so first of all, what I'm going to do is I'm going to try and add these two equations together. I'm going to call this equation 1 and this equation 2. And I'm going to add these two equations together. And I start by adding these two just because I like to do that way. So 6 add 2 is 8. Okay. And then here I've got y. I've got a positive y. And I'm going to add to that a negative y. Okay. Because as you can see, this is actually a negative y and this is a positive y. So that's like saying 1 plus minus 1. And that just simplifies to 1 take away 1. The minus wins out here, wins, okay? Again, if you're not sure about adding and subtracting negative numbers, please go and revise that. So that basically leaves us with nothing. 1 take away 1 is 0. So those y's just cancel out and they disappear. And then here I have x plus x. Well, we know that x plus x is 2x. So I can write down 2x. So I've eliminated one of my equations. And I'm now left with 2x equals 8. Okay? 2x equals 8. And I'm assuming you're familiar with solving normal equations. Otherwise, you wouldn't be graduating to simultaneous ones. But if 2x equals 8, then we must divide by 2 here, divide by 2 to tell us what x is. Okay, so x equals 4. Again, if you need to revise solving normal equations, so linear equations, please go back to find my video on that. X equals 4. So if we have x equals 4, we've solved that part of the equation. Let's just write that over there, x equals 4. We're now going to check that and see if it works and work out what y might be. So I'm going to take my original equation. I'm going to take one of my original equations. I'm going to take the first one. X plus y equals 6. Okay, I'm going to take equation 1. And I'm going to put my value for x that I've just worked out into that equation. And we said that x equals 4. So that gives us 4 plus y equals 6. And to work out y, we need to subtract 4 because it's saying a positive 4 plus y equals 6. 4 plus something equals 6. I'm sure you've already worked that out. So if we take away 4, y equals 2. Okay, I'm just going to pop that over there next to my x equals 4. And now the last thing I'm going to do is I'm going to test. I'm going to test this just to check that it's correct. I'm now going to take equation 2, x take away y equals 2, and I'm going to put both of my x and y values that I've worked out, and I'm going to put them into this equation. So I'm going to end up with 4 minus 2, because x is 4 and y is 2, and that should equal to 2. Well, 4 take away 2 is 2. So we know that our x and y values are correct. And that's it. You have solved that simultaneous equation. Okay? Okay, let's have a look at another example then. It gets harder. Okay, so here's our second example. Now the first thing we've noted, or we should be able to see, is that the numbers in front of x, the coefficients of x, are different, and the numbers in front of y are also different. Okay, so the first thing I'm going to do is I'm just going to see if I can do a similar thing to what I did before, and see if I can add them together first. Okay, let's see if adding them together gives me an eliminated equation. Okay, so 6 add 2 is 8. Okay, here we have y plus, we're adding, remember. Okay, we're adding them together. Y plus minus 2y. Okay, let's write that down. Y plus minus 2y. That's like saying 1 plus minus 2. 1 plus minus 2 becomes 1 minus 2. 1 take away 2 becomes minus 1. So we end up with minus 1y there, or minus y. Okay. And then we have 2 plus 3. 2x plus 3x is 5x. So we end up with 5x minus y equals 8. Okay, we've still got x and y's, so we haven't eliminated anything. So I can't add them together. Okay, so I'm just going to get rid of that. And what I'm going to do now is I'm going to try and subtract them. Okay, so instead I'm going to subtract now. 6 take away 2 is 4. And then here we've got y, or 1y, 1 minus 2y. Okay, I've written it like that so you can see that there's only one y, and we're taking away minus 2. We're taking away minus 2. So that becomes 1 plus 2, which becomes 3, a positive 3. That becomes a positive 3y. Okay. And then if we did 2 take away 3, that would be minus x. Minus x plus 3y equals 4. We've still got x and y's. We can't take them away. Okay, so we can't add and we can't subtract, not yet anyway. And the reason for that is because these coefficients in front of the x and in front of the y are different. Okay, they need to be the same. or at least one of them does anyway. So what we need to do is we need to decide what we're going to do to those equations in order to make either the x values or the x coefficients, the same, or the y coefficients the same. So I'm going to label this one equation 1 and this one equation 2. Now, you can choose really what you're going to do here, but you need to get those x values the same or the y values the same. Now, because y's have got some negatives in there, it's got a negative in that 2y, I'm going to leave them alone and I'm going to look at the x's. And what I'm going to do is I'm going to times this by 3 and I'm going to times this one by 2. Now, the reason I'm doing that is because if I times this first equation by 3, it will give me 6x. And if I times the bottom equation by 2, it will also give me 6x. So I'm going to do that, but I have to do it to every single term. I can't just do the x's. I have to also do the y's and the 6 and the 2y and the 2. So 2x times 3 gives me 6x. Y times 3 gives me 3y. The plus would remain the same. And 6 times 3 is 18, so that would look like that. And now I've got a third equation. I'm going to label that equation 3. And then I'll move on to this equation 2, and I'm going to times that by 2. So 3x times 2 gives me 6x. And then I've got minus 2y times 2. Well, minus 2 times 2 is minus 4, so that must be minus 4y. And then 2 times 2 is 4. Okay, so, and then I'm going to label this equation 4. So now what I'm going to do, because these coefficients are the same, I'm going to subtract. Because I know that if I subtract this top one, this equation 3, from equation 4, I'm going to take equation 4 from equation 3, it will get rid of 6x, it will eliminate it. So I'm going to do 3, take away 4. Okay, so let's do it the same way as we did it before, and we're going to start here. 18 take away 4 is 14. I'm just going to change my colour so it's easier to see. Okay, so I've done 18 take away 4, which is 14. And then I'm going to do 3y. I'm going to write this down. 3y, and remember we're subtracting, and we're subtracting minus 4y. So we need to be very careful there, because remember 2 minuses in the middle like that become a plus. So it actually becomes 3y plus 4y, which gives us 7y. So that becomes a positive 7y. Okay. And then we do 6 take away 6, just here, and that becomes 0. So those are just eliminated. So we now know that 7y equals 14. And remember, we're now just in a linear equation, and all we need to do is divide by 7 to tell us what y is. So 7 divided by 7 leaves y on its own, 7y divided by 7, and 14 divided by 7 is 2. So we now have y equals 2 as one of our answers. We can't be 100% sure that we're right yet, because we need to test it with our other equation, and we need to find x, but we'll write that there just so that we know we've got it. So what I'm going to do now is I'm going to go back to my first equation, 2x plus y equals 6, and I'm going to put my y equals 2 into that equation to try and work out what x is. So 2x plus y, and y is 2, so I'm going to put that in there, equals 6. I'm then going to work out the answer to my linear equation. I'm going to solve it for x to show what that x value is. So I'm going to subtract 2. Okay, I'm going to technically move that 2 over by subtracting it, giving me 2x equals 4. Again, if you're not sure about linear equations and solving them, you must go and watch that video. And then I'm going to divide by 2 to tell me what x is. So 4 divided by 2 is 2. So x must also be 2. Okay, let's check then. Let's do a check. Okay, I'm going to change my colour for a final time. Check. I'm going to use this equation here, equation 2. 3x minus 2y equals 2. 3x means 3 times 2. And then minus 2y means minus 2 times 2, because both x and y were 2. We need to check that that is equal to 2. 3 times 2 is 6. Minus 2 times 2 is minus 4. And 6 take away 4 is actually 2. So we know we are correct on that one. We have now solved that simultaneous equation. Okay, time for our final example. This one is actually a little bit similar, but obviously what you need to look at immediately is exactly the same as we noticed in example 2, is that neither of the numbers in front of x or y are the same. So we can't add or subtract yet. So what we need to do is we need to get them, either the x's or the y's to be the same. Now, this example obviously calls for multiplying by some numbers like we did before. So again, I'm going to leave the y's alone because there's a negative in there and I don't really like messing with those. So let's label our equations 1 and 2. And I've decided that I'm going to times by 3 and times by 2 again. Okay, it won't always be the same. You will have to decide, okay, if I had something like this, 4x plus 3y and 2x plus 4y, you might want to multiply that by 2 and that one by 4. Okay, so because then that would give 8x here and 8x here. So it won't always be the same. It's just happened to be that these were the same as the last example. So I apologise for that. You've just got to use your knowledge of maths, which, you know, I'm sure is very good by now, in order to decide, especially your multiplication tables, in order to decide what you're going to multiply by, to make sure that those two values in front of either x or y are the same. Okay, so here then we're going to multiply again and we're going to create equation 3 and equation 4. Okay, 2x times 3 is 6x. 3y times 3 is 9y. And 1 times 3 is 3. So that one was nice and easy. We're now going to multiply by 2 for this next equation. 3x times 2 is 6x. And then we have minus 2y times 2. Minus 2 times 2 is minus 4. So that would be minus 4y. And 8 times 2 equals 16. Now we're still going to subtract here. But what I've decided is I'm going to, it doesn't matter which one you subtract from which. As long as you're careful with your negatives, you won't go wrong. I've decided this time I'm going to do this equation and I'm going to take away this one. Okay, so instead of doing 3 take away 16, which would be a bit annoying, I'm going to do it the other way around. Okay, it doesn't really matter. If you did 3 take away 16 and then you did 9 take away minus 4, you would get exactly the same answer. Okay, so I'll show you that actually. So 3, if I just change my colour, 3 take away 16 gives you minus 13. Okay, 3 take away 16 gives you minus 13. Okay, and then here you have 9y, and you're going to take away from that minus 4y. And that ends up being 9y plus 4y, which actually gives you 13y. So 13y would go there, and 13y equals minus 13. Okay, and then you'd have 6 take away 6, which just become eliminated. Okay, so as you can see, we now have 13y equals minus 13. So all we have to do is divide by 13 to give you your answer. So that gives me y equals minus 1. Okay. So y equals minus 1. Pop that there. Okay. Let me just show you if I'd have done it the other way. What would have happened? Okay. I'm going to do it in a different colour. If I'd have done 16, take away 3 instead, that would have given me a positive 13. Okay. Then I would have done minus 4. If I write that over here, minus 4. And I would have, minus 4y, sorry. And I would have taken away 9y. Okay. Minus 4 minus 9 gives us minus 13. So that would have been minus 13y. Okay, so this time, all we would have had to do was divide by minus 13 to get y on its own, which would have given us y equals minus 1. So either way round you do it, you will get minus 1 if you're correct in your working out and you've not made any mistakes. Okay, so we should have y equals minus 1. I'm just going to rub this bit out because I don't want it to take up too much space. So if y equals minus 1 then, I'm now going to work out my x value. I'm going to go back to my original equation and I'm going to take equation 1, 2x plus 3y equals 1. And I'm going to put my y equals minus 1 into that equation to work out x. So I end up with 2x plus 3 times minus 1, because y is minus 1, equals 1. Okay, so that means 2x, and then 3 times minus 1 is minus 3. Okay, and that should equal 1. Okay, so positive 3 times negative 1 is negative 3. We just need to rearrange the equation now to find x. So I'm going to add 3. Plus 3 there. Oh, sorry, I don't know what I'm doing there, do I? Okay, in fact, I'll do it in a different colour though, just so that it doesn't look confusing. Plus 3, okay, and that gives me 2x equals 4, because I've plus the 3 over to the other side. Okay, so I plus 3 on both sides. And then finally, I divide by 2. So x equals, and 4 divided by 2 is 2. So x equals 2, we should have. And then I'm going to do my final check, just to make sure I'm right. And I'm going to use 3x minus 2y equals 8. Okay, and I'm going to, that means 3x means 3 times 2. Okay, and then minus 2 times y is minus 2 times minus 1. Okay, and that all equals 8. Now the reason I do that with the little brackets underneath is to remind you to include your minuses in correctly. So 3 times 2 there is 6. And then here we've got minus 2 times minus 1. And that just gives us a positive 2. Okay, minus times a minus is a plus. And we know that 6 add 2 is 8, so we are correct. Y equals minus 1 and x equals 2. Okay. Okay. So, hopefully, we have understood what a simultaneous equation is, and we have used the elimination method to solve simultaneous equations. Okay, that we definitely used the elimination method. That also came with some, some multiplication, which it looks a bit silly written in highlighter. But we've also used some multiplication in order to get the coefficient, okay, the coefficient of x or y, we mainly used x, the same, but it doesn't matter which one you use as long as they're the same, because once they're the same you can subtract them. Okay, we will be looking at a few more examples where you may be able to add, But I tend to leave the negatives out of it so that when you do get the coefficients the same, it's easy to just subtract. All right, you've got to use your own knowledge of maths to be able to figure out what you're going to times the numbers by to give you the same number as the coefficient of x or y. Okay? Okay, well done. Thank you for using Cubit Education, and thank you for learning with us, learning simultaneous equations, the elimination method, and I really hope to see you again soon.